So we are still doing relating graphs to events, and we're still working with section 1.5, looking at graphs and making situations from them. And I think they're so much fun. But what we're going to do now is we're going to even get more specific. Everything we've talked about so far has been very general, in general terms. You know, it's kind of like, that looks to be about like this. But now we're going to make it a little more specific. And I call this my monkey worksheet because the whole front side is all about monkeys, but it is really just a more specific lesson, section 5.1 worksheet that we do. So it says, number 1, suppose the graphs below show each monkey's distance from the front of the cage in feet as a function of time in seconds. Describe, so that's what we're going to do. We're going to describe each monkey's movement as complete as you can. Include the rate or speed for each segment of the graph. So now you can see how we're getting a little more specific. So as you can see, we have time on the x-axis, we have distance here on the y-axis, and this is the monkey's movement. So it says right here at 0, 0, this is the front of the cage. Okay, and it says that in the stuff, it says the distance from the front of the cage in feet. And that's going to be important that we know it's in feet as a function of time in seconds. Okay, so the distance is going to be feet and the time is going to be seconds. Now, as you can see, we've talked about ordered pairs. You can see that they have some ordered pairs here. So we need to talk about each ordered pair. So this is kind of going to be my first ordered pair. So what's happening here? Well, X is time in seconds. So this X here is 5. And then the feet, our distance is Y, and this of course is our Y. So the monkey started right here at 0, 0. This was 0, 0, so that means the monkey was in the front of the cage. And so in 5 seconds, because that's my X, so in 5 seconds, the monkey moved from the front of the cage back in the cage 15 feet, because feet is our Y. So I would say something like, in 5 seconds, the monkey moved, moved back 15 feet. So again, getting very specific using our coordinates that they give us, our ordered pairs, to describe the movement. So now here's the second one we're going to describe. So here we are starting with 10, and that refers to seconds. So it was at 5, now it's at 10. So you can't say 10 seconds now. You have to think about what has happened from this one here to this one here. So in 5 seconds, and maybe I don't even want to say that because let's look what's going on before I write. What happened? He was at 15 feet. Notice this line is straight across. So did the distance change at all? It didn't. And notice what it says here. 15 feet. So the distance didn't change. So we went from 5 seconds to 10 seconds. And then the distance stayed the same. So let's kind of word that together. So the monkey stayed, something about like that. The monkey stayed at 15 feet back in the cage for, and how long did he do it for? 5 seconds. Because remember, what they said in the directions is they want you to include the rate or speed for each segment. So that means you've got to include time as well as distance. So you have to do both. Okay, and then number 3, here's the third one. So here's the third coordinate we have to check out. So the X is now at 12. So how much time has elapsed? Well, that would be 2 seconds. And what happened in 2 seconds? The monkey looks like it went from 15 to 25. So the monkey moved 10 feet. And which direction did the monkey move? Again, it moved back further in the cage. So that's what we want to talk about. So in 2 seconds, the monkey moved 10 more feet back in the cage. So that's what you're going to do for B and C. When you do B and C, actually there are really kind of 4 points. I didn't really start with 0, 0. I probably should have, but here you're going to start right with 1 describing there, and then you've got 2, your description there. Then you have a description here for 3, and then you have a description here for 4. Same thing with C. You're going to start here at 1, what's going on, 2, what's going on, 3, what's going on, and 4, what's going on. Okay, so being specific, writing those down. All right, second part. Again, getting more specific. Now it says sketch the graph. So we're sketching just like we were doing before. A graph of a distance and time function that could match each monkey's movement again. Put in coordinates for all the important points on a graph. So the first monkey was 10 feet from the front of the cage. Moved 3 feet closer to the front in 3 seconds. And stood for 2 seconds. And then walked back to its original spot in 2 seconds. So what we're going to do is we're going to kind of do, just like what we were doing before, we're going to go from here, and then we're going to actually draw in the graph. So we're kind of working backwards from what we were doing. So the first monkey was 10 feet from the front of the cage. So once again, we probably need to put a title. So time in seconds. And notice there's never any numbers on these number lines. And then we have distance and feet because everything's general, but you can see how we're getting more specific here. And then of course we need a title. So we're going to say monkey moves or something like that. Sounds good to me. All right. So it says the first monkey was 10 feet from the front of the cage. So at 0 time, that's at 0, it was 10 feet back. So we're going to put a dot and we're going to make that 10 feet back, and we're going to write a coordinate. So this coordinate is at 0, 10. So that takes care of the first part. The second part says he moved 3 feet closer to the front in 3 seconds. So 3 seconds elapsed. So as we go across the time, we're going, 3 seconds, kind of think of that. And then he moved 3 feet closer. So he's getting closer to the front of the cage. And remember, down here is the front of the cage. Front of cage. So he gets closer. So in 3 seconds, so now my time is 3, he moved 3 feet closer. So it was at 10, and moving 3 feet closer, you would subtract 3 from that. And so my new coordinate would be 3, 7. And I'm going to draw myself a line. From there, he stood for 2 seconds. So again, time has elapsed 2 seconds, but he stood there. So his distance didn't change, so I go straight across. And so that would be 5, 2 seconds elapsed, that's my X. And he stood there, so now he's still at 7. He hasn't moved. And then last but not least, he walked to his original spot in 2 seconds. So now he's back to his original spot at 10 feet and 2 more seconds elapsed. So I'm going to kind of go like this. 2 more seconds elapsed. So now I'm at 5 plus 2, which would be 7. And he's at his original spot, which was the 10 feet. So a good graph, of course, has title, has both axes labeled. And of course, now you're going to be more specific with your information. Boy, I've kind of made a mess of kind of that stuff. But you are going to draw in what the specific movement looks like. Okay. On the back of the worksheet, it says choose the graph of distance as a function of time that matches each situation. So now you have 6 situations, and you have actually 1, 2, 3, 4, 5 different situations. You have 6 graphs, I guess I should have said, and now you have 5 situations. So now you have to look at each one. You're going to have one that doesn't belong. And you're going to have to see which belongs with which. So one of the situations to match the graph is riding a Ferris wheel, and it's the rider's distance from the ground. What would that look like? So think about a Ferris wheel. What happens in, of course, it says it's a function of time and distance. So of course, time is going to go here, and then distance is going to go here. So what would actually happen? Which one would be the Ferris wheel, so on and so forth, okay? B, running sprints back and forth, the distance from the starting point. The Earth and Sun, the distance, Earth's distance from the sun, what would that look like? The space shuttle flight. The space shuttle's distance from the Earth. What might that look like? And then riding an elevator to the top, stopping at each floor, and that's the rider's distance from the ground. So there are 5 you need to match up. And I don't care how you do it, but like here's situation A. The easiest would be, oh, that's graph number 1 or Roman numeral 1. You could just put it up here. Situation B, that's graph number 6 or something. And so you'd put VI. Okay, so that's kind of probably the best way to do that. Now, obviously, those are not the right answers. So let me erase those. All right. Number 4 says, which graph above cannot be a graph of the distance a function of time, and explain why. So the one that you don't choose up here, the one that you do not choose, the one you did not choose from above goes here. And when you did not choose it, I want you to explain why it didn't work with one of the situations. And then 5 and 6 are pretty easy. It just says the value of Lynn's house first increased, then remained the same, and then the value decreased. Decide which of these graphs below showed the value of Lynn's house. So this is just the one situation. It's just kind of multiple choice. Is it A, B, or C? And then last but not least, it says for the remaining 2 graphs that you did not choose for 5, write a statement that would accurately describe the value of the home. So the 2 that you did not use, 2 you did not use, would go here. Okay, and you would describe exactly what's going on. All right, you are going to work on this worksheet, finish it up, taking situations, but being more specific with things. Good luck.